Today in the Checkerboard Kitchen, we will learn to make our own liquid foaming hand soap using these two simple ingredients. We will then use the soap to refill this empty hand soap dispenser. Welcome back to our instructional video on how to make your own foaming hand soap refill from standard liquid hand soap and water. Use rag here. Okay, I was going to plan this whole elaborate science experiment, which I use to determine how to make it, but we're going to give you the quick and dirty version, and maybe I'll throw in a little science in there as well. So basically what we have is the standard hand soap, as you can tell, is very gel-like and very thick, versus the foaming hand soap, which is very water-like and thin. When I started examining both products, I noticed that the commercial pre-made foaming hand soap feels like water, except it has a very slippery, soapy texture to it. And the the standard non-foaming thick hand soap, once you put water with it, it would dilute down and become very watery as well. So I made the assumption that whatever they're putting in here came from something thicker. And if you look at the ingredients, one of the ingredients is water. In fact, number one ingredient is water, which tells me that this was made by adding something to water to create this consistency that is used as the basis for the soap. So I further made this assumption that the foaming hand soap must be a more diluted form of this type of soap, or at least something close to it. The actual formulation is slightly different, but there doesn't appear to be anything in the foaming hand soap that would aid the foaming process. So I think it's just a matter of getting the right mixture so that the soap water ratio produces the best foam. Not wanting to try to re-engineer their soap, I decided to take on the experiment of trying to figure out how much to dilute this product to turn it into something like this. Okay. Well, for any of you out there who actually make your own beer, the solution is rather straightforward. Basically what I did, okay, now we got to get into a little science. If you remember from your high school chemistry, if you measure out 1 liter of water, it's going to weigh 1 kilogram. So therefore, 100 milliliters of water will weigh 100 grams. If you have another liquid that is water-based, and you weigh it and find out that it weighs more than 100 grams per 100 milliliters, that means that something's been added to the water. So, with that information in mind, I went to my trusty little graduated cylinder here. This is a little cheap plastic one, which you can get on Amazon real cheap. This one does 10 milliliters. So I calibrated it by adding 10 milliliters of water and finding out how much it actually weighed, which tells me how accurate the cylinder is. And it was off a little. Not to be unexpected, since it's not high quality laboratory grade measuring devices. Then I did the same for the foaming soap. And what turned out to be is that the foaming soap was 1.05 times, had a specific gravity of 1.05, which means it's 5% heavier than water per equal amounts of volume. Then I did the same thing with this soap, which is a little tricky because it's really, really thick. And it turns out that this is 1.2 times as thick as water. So with those two numbers, 1.2 and 1.5, you can go online or just do the math and plug it into a dilution calculator. For any of you that make beer, those are all over the place. You know where to find them. Turns out that what you do is to get this diluted down to the same consistency of this is you take 25 milliliters of the soft soap and add enough water to make 100 milliliters. So it ends up being like a 3-to-1 ratio. So I'm going to measure that out next and show you how I did it. Okay, I've got everything ready. First, well, since unit of measures don't make any difference, whether we're working in milliliters or cups or gallons or whatever, it makes no difference. So what we're going to do is we're going to fill, since these containers are about 8 ounces, 7.5 ounces, and I have another bottle that needs a little bit more anyway, I'm going to make 1 cup of the solution. So the way I'm going to do that is I'm going to start out and we're going to add 1/4 cup of the soft soap. I was thinking though, if they call this soft soap, does that mean regular soap is hard soap? I'm not really sure. I'm getting a little to the bottom. Luckily, I brought another prop here, which is a hand size pump. I was going to do an experiment on how much money we actually save by using this. So let me pump the rest of it out of here. As you can see, this stuff is really, really thick, which is part of the waste. If you squirt some of this on your hands and try to wash your hands, half of it's going to go down the drain because it won't dissolve fast enough under the water to be useful. Okay, need a few more squirts here. Doesn't have to be perfect, but the idea is not to make it too thick or it may not foam correctly, or make it too runny and it won't foam correctly. All right, I pre-measured out 3/4 cup of water. So we'll add that to the mixture to bring it up to about 1 cup. There we go. And we'll use a kitchen whisk to mix it up thoroughly. I want to dissolve all of that thick soft soap in the water. Now the cost savings here are that if you buy one of these containers like this, it's going to cost a little over $2. And because you're paying for the container, it ends up costing about 25 cents an ounce. If you can buy pre-made foaming hand soap, which for a 50-ounce container will cost about $5. So you can refill your container for about 10 cents an ounce. Now you can get one of these containers for around the same price as you would the pre-made foaming hand soap mix or liquid. But as you saw, we're diluting it 3-to-1. So you're basically getting the equivalent of or each one of these will make 3 foaming hand soap solution bottles. So already it's a lot cheaper. Plus, if you're like me, I don't like the fragrance that they put in these. This one happens to be green tea, which doesn't really smell. But if you like a different color, you can put a few drops of food coloring in. You can add some of your favorite oils of whatever flavor, lavender, whatever you want, to get your own fragrance. It's up to you. So once we have it all mixed, we just pour it into our bottle. And see how runny it is? It's almost like water in this case. Okay, so we have it almost to the top, and we leave enough space for the foaming This little mechanism is a foamer. It mixes air with the liquid as it comes up, and that helps produce the foam. So basically that's it. It may take us a few pumps here to get it going. Oh, there we go. And there you go. Nice foamy hand soap. I'll be back in a moment. Okay, I ended up washing my hands after all that. Okay, another reason why this is a good idea is if you're environmentally conscious, you are going to waste a lot less soap down the drain. And in the case of this soap, it's antibacterial. So you're not putting a whole lot of antibiotics down the drain, which is fastly becoming an item of worry for the environmentalists. And they've already taken a number of the chemicals that are used in antibacterial soaps off the market. Second thing is, as I mentioned before, you aren't going to waste as much, because when you squirt some of this on your hand, there's no way you can get as much efficiency and use as you can with the foam. Third part is, how much of this do you really need to wash your hands? Well, when you push the top, you get a metered amount from whatever this pump delivers, which is probably the same as about 10 pumps of this. One pump of this, if you've used it before, will clean just about any problem you have from working around the house. If you're working out in the yard or on your motorcycle or whatever, you probably won't be using this to clean your hands anyway. But for around the house, this is great. I've had this bottle. I was going to look for the date. There's no pull date on these, of course. I think this bottle is probably 5 or 6 years old. It lasts a long time. So you buy a couple of these initially, use them up, refill them. I bought this one as a prop. I'll use it eventually. Since I'm pretty much out of thick soap, I'll have to use it anyway. So I have one of these in the kitchen, one in each bathroom. Perfect. I'll put the formulas that I used, the mixture formula, in the text below the video. Clean hands and enjoy. Oh, one more thing. While putting this video together, I realized there's another type of soap that I use, and I wondered if it would actually work better if it was in a foamy solution as well. That's the kitchen dish washing solution, like Dawn or Palmolive. I happen to have a cheap dollar store knockoff product. So we're going to try it and see if it will do the same thing, since I have an extra container we can try. So what I did was I tarred the container here, my little 10 milliliter graduated cylinder. I poured 10 milliliters of the dishwashing detergent into the cylinder, and we're going to weigh it now. Now, if it was water, it would weigh 10 milliliters, or 10 grams, excuse me. And if you take a look here, you'll see that it weighs 11 grams, which means it has a specific gravity of 1.1 compared to the 1.15 of the soft soap. Call it fate, but when I went to retrieve some dishwashing detergent from the pump bottle I was using, this is a non-foaming kind, the pump broke. So this little experiment better work anyway. So as I pointed out, the specific gravity of this soap is 1.1. So to reduce the specific gravity to 1.05, we need to double the amount of water, cut it in half, basically. So I'm going to continue to add. Now, of course, whatever product you buy, your results may vary. I'm not sure how long this is going to last me anyway. So I'm going to fill this up to 2 ounces and add a couple ounces of water. Bring it up to 4 ounces or half a cup. Okay, close enough. And we will thin this out. Now, normally, when you probably use the soap in your kitchen more often than you use it in your bathroom. If you're doing lots of dishes, you end up a lot of greasy dishes. You end up squirting a lot of this onto a sponge or a cloth to clean your dishes. So I'm not sure how this is going to work, but it's worth a try to find out. So now we have all mixed up. We will pour it into a empty bottle. Now note the green color. I already noticed that the foam that's created, any foam that's created from this mixture is white. It's just that it looks white because the amount of dye they're using isn't enough to color all of the surface area of the bubbles. So when we're looking at reflected light off of the bubbles, they look white. If we examine them more closely, we might be able to see a slight tinge of green. Okay, I cleaned out the pump unit so there isn't any of the residue hand cleaner in it, and we'll see if it foams. If it does, we'll give it a try in the kitchen. Stuff doesn't take very long to come out. Sure enough, there's dishwashing foam. So I'm going to give this stuff a shot to see if it works just as well. I may need more pumps, but again, I'm not going to waste as much. I'm not going to waste as much by having it dissolve away into the water. More of it will get onto the cleaning item or sponge that I'm using. So hopefully this is useful. I'll put the formulas I used in the description. That's pretty simple algebra. So head out to the store and make your own.